All right, so hello everybody. So what I'm going to be doing today is actually going back to the Talos, and the reason I'm going to be doing that is that I'm going to be showing you a sort of a alternative method of doing stem alignment. Okay, so I will be if you've seen my previous videos on Talos alignment and stem alignment in general, you'll know that the method uses the Ronchigram, and there's nothing wrong with that. Okay, the Ronchigram method is perfectly fine. But what I will freely admit is that it's difficult for a lot of people, especially new people, to kind of wrap their head around what they're seeing when they look at a Ronchigram. Okay, and so it's not necessarily the most intuitive thing, and that's particularly true when you're doing the beam tilt adjustment, also known as the rotation centering. So what I'm going to be showing you today is an alternative method of doing the stem alignment that works just as well as the Ronchigram method, but is a little easier to perform, okay? Especially with the rotation centering step. Now, it doesn't completely avoid use of the Ronchigram. Okay, there's still some use of the Ronchigram involved here, but it is diminished substantially from what was done previously. Okay, so once again, this is raw, unedited, uncut, live. Whatever comes out, good or bad. Okay, so we'll get right on it here. So before we start again, I'm going to load the alignment file. If you have a gun setting for stem, which we do here, we can go ahead and apply that. So again, usually with the Talos or the Technis for that matter, this could also be applied to the Techni. You typically are using a higher value of the gun lens, so we'll go ahead and set that. And then we'll go ahead and open up the column valves. So the sample I have in here is just the gold replica grading. So let's go ahead and mag out here until we can see something. Oops. Looks like the beam is a little out of sorts. If this happens to you, by the way, okay, so I should actually do a separate video for this, but usually sometimes the beam position gets out of off center. If you go to the if you find the direct alignments panel here and you click beam shift, that will usually center it. So looks like it's maybe still over something, so we'll keep going out here. Where are you, beam? There we go. Okay. All right, so oh my goodness. Now I very, very, very briefly plasma cleaned. Okay, so here's some good spots in here. I very, very briefly plasma cleaned this grid for literally a mere like 3 or 4 seconds. Looks like it nuked some of the holes pretty good, but it looks like there's still some other ones on here, so we should be okay. So before we get into stem mode, really the only thing that we need to do is establish Eucentric height, okay? And so once again, we want to be in SA mode when we do this. Okay, so go into SA mode. You don't have to be too high, somewhere in the, 10,000 range. Press Eucentric focus, and then we're going to focus by adjusting Z until we get minimum contrast. Yep, right about there. Okay, let me change this to high contrast. That might be a little easier to see. right about, boom, right about there. So it's pretty subtle here. Maybe it's a little easier to see with linear mode. Yeah, so you can see right about, boom, right about there. Okay, of course you could do this the rigorous way, okay? Go to the, find the stage panel here, and then turn on the alpha wobbler, okay, 10 degrees. All right, so it's pretty close here. You're talking about, you know, less than half a micron a swing, so it's fine. Again, if we wanted to be, you know, nitpicky here, we could maybe make this a little more accurate. So I'm just finally adjusting Z-axis on my right-hand panel, but that's good enough. All right, from here, we can go into stem mode, so we'll find the stem tab, and then we'll click the stem button in the stem imaging control panel. All right, so first thing I'm going to do here is make sure that my indicated stem mag is not at some ridiculously low number. I've seen this cause issues. So what I usually do as just a default is I'll set it to 225 just for the alignment purposes, okay? Now, once we're into stem mode, okay, we need to pick the spot size. So if we go to the beam tab, we can pick the spot size. So again, down here on this end is where you're going to get the smaller probes. This is going to be your bigger probes with more current. So for our purposes today, why don't we go ahead and we'll go ahead and use 8. So usually 7 to 9 here will give you atomic resolution. I don't usually go, I know in a previous video I've used 10, but I've actually kind of walked that back now. The reason being is that the current at 9, what I find here with the, you know, with the aperture put in is around 10 picoamps. So going to 10 probably doesn't give you a whole lot of benefit in terms of maybe a reduced probe size, but you're obviously losing a lot of current. So my default for the best possible resolution now, I leave at 9, but we'll put it at 8 here just to make it a little easier to see, okay? Just to give us a little more signal to noise in the picture. Okay, so now that we have the spot size selected, okay, we are going to generate an image of the probe on the FluCam, okay? So right now we have, if you look on your right-hand panel, your diffraction button is going to be on. Okay, so the imaging system of the microscope is in diffraction mode. Okay, so that goes back to like right here, you're seeing you have a camera length, right? So what we're going to do is we're going to switch it from diffraction to imaging, and all I have to do is click diffraction on my right-hand panel, and then now instead of a Ronchigram, I see an image of the probe right here. Okay, let me switch this to HDR. It's probably going to be a little easier to see. Okay, there we go. All right, so you can use the trackball here just like you would in conventional mode to move the probe around. Okay, it's a little bit different. It's not, it doesn't have the same orientation, but you can use it to shift things around. Okay, as far as the mag, so you see now it says SA here. Okay, before there was nothing, right? It just had a number, but now you have SA. Okay, so you can adjust this with the mag knob to whatever you want. Okay, but for alignment purposes here, I usually set it at 190. I think if we bring this up, where does it top out at? Yeah, it tops out at 630. You really don't have to go that high, in my opinion. You know, somewhere around 245 or 190 usually works fine. So, and it makes it, and it works, you know, fine for doing that. But you could go higher. I wouldn't go lower than this. Okay. The other thing to keep in mind too is what your focus knob is adjusting. Okay, so if we expand this little panel here in the stem imaging and we click on focus, okay, I have it set to intensity. That means that your focus knob is only adjusting the C2 lens. Okay, the objective lens stays fixed and you're not doing anything with that at all. Okay, the only thing that's being tweaked is the C2 lens. Okay, so you can see if I push, just push Eucentric, yeah, so it didn't change any of the values. Okay. So those of you who are using this machine, okay, this isn't something you need to worry about. It's already set to this. You don't have to worry about it. But those of you, on a different machine, this is what I recommend you do with the Talos Techni specifically. Okay, is you don't mess with the objective, and you just mess with the C2 for the focus. All right, so anyways, first thing we're going to do is align the C2 aperture. So this is in essence no different than what we would do in regular mode. Okay, so I'm going to start by making my probe as small as I can make it, right about there. Okay, all right, so from here, I'm going to go clockwise, right? So I get now instead from, so right here where we have the focus spot, we call that a caustic spot. If I expand this, okay, so I'm expanding this, turning the focus knob clockwise, so it's a little bit bigger now than this, second smallest circle. Then I'm going to go ahead and center this. All right, and then I'm going to keep turning the focus knob clockwise until I get it just outside here. Let me change this up to make it a little easier. Okay, so you can see this isn't centered. Okay, so then we're going to find the apertures panel. I have it here in the Tune tab. And then we want the 70 here. That's the optimal one for stem resolution. And we click Adjust. And then we center. So this is, in essence, now no different than what we did in regular mode. Okay, the process is doing it is the same thing, essentially, except now we're in stem mode, aka nanoprobe mode. So we'll go back down to that same size. Go ahead and recenter. And I'm recentering it with a ball when I go back down here. Okay, I'm not recentering with the apertures. Then we re-expand it. Okay, and that looks pretty good. I'll make one final tweak. Usually 2 iterations here is enough for this. The other thing to keep in mind is this will be somewhat spot size dependent. Okay, so that's why first thing you do is you set the spot size and then you go and do the rest of this. All right, so we have the C2 aperture aligned. For the next step, which is the rotation center, this is usually good to do on some open area. So if you have vacuum, that works great. We don't have vacuum here, but we do have some open parts, right? We can see the film here. So we can see this is like open and this is the gold particles. So if we put this right here in the middle, okay, that's going to make this a little bit easier to do. Okay, and then I'm going to turn off these circle marks because that's also going to make this a little bit easier. And then I'm going to take the focus knob and I am going to focus it until I obtain this caustic spot right here. Let me switch to HDR. Might have been a little easier in linear. So now here, if you wanted to change the mag a little bit, you could. So let me bump the mag up a couple clicks. Might make it a little easier. Okay, so right there, I've got this spot. Okay, you can see now this caustic spot is not centered inside this diffuse area. So that means our rotation center is off. So if we come here, we find the direct alignments control panel. I have it here in the Tune tab. You can click rotation center. Either of these will work. Objective intensity doesn't matter. Okay, I'll click intensity. Now when you do this, you may see the beam shift suddenly. Okay, so if that happens, we just have to mag out. Okay, and then we have to bring it back. I don't know why it does that, but it does. Okay, so we'll come back up here. All right, and then you're going to see that diffuse area kind of pulsing. If you take the outer focus ring, you go counterclockwise, that'll turn that off. So let's see, where's our diffuse area? Okay, so there's the amorphous carbon right there. All right, so there we go. All right, so now use your multifunction knobs, okay, and watch what happens. Using the multifunction knobs, and I'm centering that caustic spot inside of that diffuse area, just like that, okay? So this is now taking care of the rotation centering, and I think we can all agree this is probably a lot easier than trying to do this via the Ronchigram method, okay? All right, so we are good to go now in terms of the C2 aperture and the rotation centering. Let me just make one more little tweak here. Okay, that's good. Now, one thing you could do, I'm going to click done. One thing you could do if you wanted to, and this is, strictly speaking, not critical, okay, in my opinion, but you could balance the pivot points here. Okay, so if let me switch to natural mode. Okay, get the beam as small as you can get it, right about there. Okay, and then in direct alignments, you can do NP beam tilt, PPX, and PPY. Okay, those of you who are using this machine that I'm working on, this isn't an SOP, so don't worry about it, but I know some people might ask, so I'm going to put it in here anyway. So we click this guy. Okay, so now we get these wings here, and we want to get these two tips here to touch. Okay, so we use the multifunction knobs. So what this does is it establishes what's called tilt purity. Okay, so tilt purity means when the beam is tilted, it doesn't move. Then we'll do the same thing for the Y. Now when we do this, we may have to go back and check the rotation center. I'm not sure, we'll have to take a look here. Okay, so it looks like to me, let's see here, find that area again. All right, so it looks like that might be off a little bit. So we'll go back to rotation center, and once again, it moved out of place on us. Okay, turn the outer focus ring counterclockwise to turn off the pulsing. And now, so now you can see what's different now is when I'm adjusting the multifunctions, meaning I'm tilting the beam, you see that caustic spot isn't moving. Okay, so I have tilt purity now. Okay, and again, I'm just centering that caustic spot inside that diffuse area. And we are good to go. All right, and again, strictly speaking, that's, the pivot points are not terribly critical here, in my opinion, okay, but you can do them anyway if you want, okay. All right, so now we're going to go back to diffraction mode with the imaging system, okay. So I'm going to push diffraction on my right-hand panel, and we are going to, again, see the Ronchigram right here. We're going to go back to the STEM tab, and now here's where we still need the Ronchigram, unfortunately. Okay, so I'm going to start by increasing my camera length to allow us to see this a bit more magnified. So I'm going to go to 520 here. Okay, and now I'm going to turn on my circle markings. Okay, I'm going to go back to the Tune tab, and I'm going to click diffraction alignment, and I'm going to very precisely, let me switch the flute cam here to natural, might be a little better. Okay, I'm going to very precisely center the Ronchigram here. Okay, the reason being is that this is going to serve as the reference point for when we swap the C2 apertures. So I know when I put the 70 micron aperture back in, this is where I have to put it. Okay, because I already centered it. I don't want to have to center it again. All right, so go ahead and click done. And now we're going to change C2 apertures to the 150 so we can see a larger range in the Ronchigram. Okay, if this is not centered, you can go ahead and click adjust. It looks pretty good, but I'll go ahead and do it anyway. All right, there we go. All right, and then we want to get a blow up condition here. There we go. All right, and I'm going to turn off the circle marks. So now what we're looking for here, this is where we're checking for the shape here of the blow up area. Okay, so we want a nice circular area. Okay, and if we don't, this is where we have to correct the condenser stigmators. Okay, so if you see, and this is a coarse adjustment. Again, the fine adjustment will need to be made actually looking at the image, but this will get you pretty close. Okay, and again, if you can do this on a purely amorphous area, that will be better than doing it on something crystalline. but this is still pretty good. So you can see, right, I'm going back and forth with the focus. Ronchigram's expanding straight in and out, okay, which is good, right? That means the rotation center was done properly, okay? All right, so you can see, it's probably pretty easy to see there, right? You can see I don't have a circle anymore, okay? And now I'm back to that. Now on my screen here, this is actually, the circle is actually a little bit more of an oval because of how the computer is, stretching the interface, so keep that in mind, okay? But normally it would look like a perfect circle, okay? All right, so that is, it's good, right about there. Okay, we'll click none, and then we go back to the 70, and I turn the circle marks back on. Okay, and now usually this will go back pretty close, but you always want to, don't just assume that it will, okay, and tweak it if it needs to be, and put it back properly if you need to. Right, because it's always going to be a little bit of hysteresis here. Aperture drive's been cutting out on us. Okay, that looks pretty good right there. Click adjust. All right, so we are good to go with the aperture centering, the rotation centering, and the coarse condenser astigmatism adjustment. We can come back to the stem tab and the stem detector panel, and then decrease this camera length back to something a bit more useful for doing HADF. So something around 160 is good as a default. Okay, and then we can go ahead and click search. Please pick a detector. Oh, what's going on here? Oh, there we go. All right, I don't know how that got disabled, but all right, there we go. All right, so, all right, we can see the detector rim here. We want to check to see, I'm going to turn off the marks again. Is the Ronchigram centered inside the rim? Looks pretty good. If it's not, come back here to tune, click diffraction alignment, and then you can shift this around so it's centered inside the rim, okay? So I think previously I was using some shorter camera lengths. You could use a shorter camera length. Your signal's going to suffer a little. I've actually started defaulting to the 160 here, okay, because this is about 50 millirad intercollection angle, which is fine for HADF, but it buys you a little more signal, okay? All right, from here, let's go to Velox. We'll go to acquisition. I'm going to have to probably, I'm going to have to close this and restart it because I had this on the other monitor before I plugged in my camera. All right, there we go. Okay, scope tool. Let's take a look here. All right, that looks pretty good. Now, one thing I want to make mention of, okay? So obviously this is not a single crystal, this is the replica grading, okay? If we were working with a single crystal, we would be doing tilting, right, to get to zone axis, okay? What's gonna happen then is we have to be careful about maintaining Eucentric height, okay? So one of the things we can do is we can be really careful and we can mag in, right? Because right now we're at Eucentric, okay? We haven't tilted the sample, okay? Turn on, right? Turn on the focusing and just get, get a good focus here. Okay, it just doesn't have to be like atomically perfect right now, but just like rough, okay? Let me see here. Okay, the other thing you could do, and now if we tilt, okay, and we don't make very strong changes to the focus, we would refocus by adjusting the Z. But what can happen sometimes is you can throw the focus way off without realizing it. Okay, so a good thing to do if you're going to be doing tilting is to come here to the Tune tab and click this guy. Okay, so if you click Intensity List Focus, okay, image is going to go out of focus. Okay, now what you're going to do is use your focus knob and get it back in focus. Okay, now what this is going to do, there we go. Okay, and we'll click done. Okay, so now what this does though is if you are unsure about the height, okay, if you press Eucentric focus now, the C2 lens is going to come back to this value, okay? Again, we're not messing with this because we're only adjusting C2 with the focus, okay? So let's say I throw this guy way off, okay? So I clearly, okay, I don't have proper focus here, okay? If I press Eucentric focus, okay, and I'm at Eucentric height, let's wait a second here. Well, it didn't work very well, did it? Let me see here. Oh, it didn't work quite as well as I thought. So yeah, I'm not sure why with this guy it didn't work as well. So that's kind of strange. I didn't think there'd be that much hysteresis here. Okay, so I guess in this case, the intensity list doesn't really help. I mean, if we try, let me try it again one more time here, just for fun, because we had to make a pretty big adjustment the first time. Okay. All right, so let's click done now. All right, so let me try it again here. So if I go way out of focus, click Eucentric focus, see if it comes back a little bit better this time. Ah, there we go. Okay. So I think what happened was the first time it was so badly out of whack. Okay, so I had to do a couple iterations with that. I went the other way. Let me just check here. Ah, boom. Okay, perfect. All right, so the key here, okay, let's say I had to tilt this, okay? So if I come back here, this looks okay. Sometimes when you do eccentric focus, if it does normalization, this might shift, but it looks pretty good. So if we go here, I'm just going to adjust the alpha tilt, okay? Well, actually, let me adjust the beta because the beta is not eccentric, okay? So let's watch this right here. Okay, so I'm going to adjust this. Oh, I have a single tilt holder. Well, that's not going to work. All right, let me do the alpha. Okay, so it is eccentric and alpha, but the eccentricity is obviously not perfect. Okay, all right, so there we go. So we can see we're clearly out of focus. All right, so now we're at the proper setting for the C2. Okay, so we wouldn't want to refocus by adjusting C2. We would want to refocus by adjusting the Z-axis buttons, okay? But let's say for some reason you end up you end up throwing off the C2 lens anyway, okay? So you're tilted, you're deviated from eccentric slightly, you have the focus maybe not at the right setting, okay? So let me actually do that, right? So I'm going to put it at not the right setting here, okay? And then if I push eccentric focus, that gets me to the right setting, okay? And now I can refocus by adjusting the Z to get me into a rough focus. Now you can do this by looking at the image. You can do this by looking at the Ronchigram as well for the blow-up condition. I prefer to look at the image here. It just seems to be a little more intuitive for people, okay? But now we're good, okay? All right, so let me keep going here. Actually, let me put this back. All right, so let me just reset alpha. Okay, so again, I didn't mess with C2, so I'm going to refocus now by adjusting Z. Now, one thing to keep in mind, if you do that intensity list focus, that does not get saved with the alignment file, okay? So that is only for the session. So the next time somebody comes here and reloads this file, that is going to end up throwing that off, okay? So that's something that you have to keep in mind. All right, so just for fun here, let's see if we can't get some atomic resolution with the gold. So it's always kind of tricky here with the gold. Okay, there we go. This is much easier on a large single crystal to do, where you have nice, well-defined zone axis. So this is still off by a little bit, maybe. So we just need one good spot here. The problem is we got to find a good spot. And of course, some materials are easier to do this on than others. Let me try one more spot here really quick. Yeah, you can kind of see it coming through there, but oh, there we go. Okay, so there's a good spot right there. Sample's probably building up a little contamination as well. All right, so that's not too bad actually. That's about as good as we can expect here, reasonably, with this. All right, so there we go. Yeah, so you can see it coming through here. We'll take a single frame here just to see what we get. Yep, scope looks good. Yeah, so you can see it right there. Yep, and there. And there as well, and there as well. So about as good as we could expect to get, on the gold with a non-corrected instrument. All right, so anyways, that is the alternate stem alignment method that I wanted to share with you guys for the Talos. You could also interchangeably use this on the Techni. I think on a non-corrected Themis, you could also, not Themis, sorry, Titan, you could also do the same thing, okay? All right, so that's going to conclude the video. As always, ask if you have questions, and I look forward to seeing you guys again very soon.